Okay, so we just saw this structure. By the way, I didn't mention, but this is the second set of weights, so it's got a 2 here, right? We already used 1 here for these weights, so here we have another set of weights, so that's got a 2. Okay, now um, we want to talk about this O function that we mentioned, the output function here, or here, okay? And this whole process, by the way, is called f of x. So we start with an input layer x, and after repeating it, processing it through, we finally do O to it, and the whole thing we refer to as f. Okay, anyway, going back to this, we want to talk about this O function now. Okay, so the output function, if we're just doing binary classification, we only have 2 classes, like sweet and sour, then we can just use the sigmoid function as our output function. We can just use, for the output function, we can just use the sigmoid function. But many times we're doing not just binary classification, but we might try and classify some, maybe some people as upper rich, medium income, lower medium, and so on. So we'll try and classify them. We'll have more than one class. Okay, so in that case, we won't use the sigmoid function. We'll use something called the softmax function here. So if it was just one class, then we would just say, given an x, well, we would just say, given an x, what's the probability that y is equal to 1 versus what's the probability that y equals 0? But now we have more than just 1 and 0, or more than just 2 classes. So we'll say, what's the probability that y is in one of these particular classes? Okay? And so basically we want to have a vector of probabilities, a probability for each of the classes, for each of the categories in the class. So we want to get a vector, so I use these angle brackets here to say that we want a vector, and the first element of that vector is going to be the probability that the input is an object of type class 1, and the second element in the vector here is going to be the probability that it's of type class 2, and so on all the way up to the last class. So we're going to output a vector here. We're going to output a vector, and the elements of the vector that we're going to output are the probabilities that the input is of each of the possible categories or each of the possible classes. Okay, so how are we going to do that? How are we going to assign the probabilities? We don't use the sigmoid function now. We're going to use this function called softmax. And the way it works is we take the input, whatever is being input, so we get the input from what goes into here, all these elements, give us the input vector, and the input is also a vector, and so it has components, and we take the first component and we take e to that value, and we take the next component, and that's the first element in this output vector. That divided by this is the first element in that output vector. And then we're going to have another element in the output vector, and so on, all the way out to here. The last element in the output vector is going to be the last element of this vector A, and put that in the exponential function, so it's going to be e to that one, and then divided by this thing. So what is this thing here? This is just the sum of all these numerators. It's the sum of all this. So we got e to the a1, and we have an e to the a2, and we have all the way up to e to the ac, and we're just summing all of that up and putting that in the denominator. So what that means is that these can be now thought of as probabilities, and when we sum them all up, when I take this whole thing plus the next whole thing plus the next whole thing all the way out to the last whole thing, when I add those all up, I'm going to get 1. Right? That should be fairly clear. So this is, each of these can be considered a probability, and when you add them all up, they add up to 1. So that is what's meant by the softmax function, and that's what we're going to use for our O function. That is, that's what we're going to use as the output from here. Okay? It's going to be a vector, and it's going to be the probabilities or estimates of the probabilities for each of the possible classes. Like we said, instead of just sweet and sour, let me change the example. Maybe it's sweet, sour, hot, spicy. Well, I guess hot and spicy are the same. Sweet, sour, spicy, and bland, let's say. So we have 4 categories. So we won't use, in that case, sigmoid function. We'll use the softmax. We'll have 4 categories. So the first one will be like the probability that our estimate of the probability that it's sweet, and the next one will be our estimate of the probability that it's sour, and the next one will be our estimate of the probability that it's, what did I say, spicy, and the last one will be the probability that it's bland. Okay, and this t here just means that it's a just take the transpose. So this is I guess this is vertical when you take the I'm not sure, but the transpose is going to change it from either vertical to horizontal or horizontal to vertical. Okay. Okay, and finally, once we have the probabilities for each of them, whether so we put something in and then we say, is it spicy, is it sweet, is it sour, is it bland? So which one do we choose? Naturally, we just choose the one that got assigned the highest probability. So if spicy got the highest probability, and we'd say that for the given input, we'd say it's spicy. Okay, we predict the one with the highest estimated probability. Okay, and then finally we want to discuss how we express all this if we want to have multi-layers. So we talked about one hidden layer, but what if we want to have more than one hidden layer? So it just gets the notation gets a little bit more confusing, but it's the same idea. So let's come back to this in the next video.